Hey, so I had a lot of students ask me during office hours about question 2 on challenge 5, and specifically about what the question was actually asking for. So I thought I would make this short video to clarify what it is your algorithm is supposed to do. So we have as input a list of numbers. And by the way, for this question, you can assume that the length is a power of 2. And in this list, we're going to consider different subsequences, which you can think of as list slices. So for example, this is a list slice, this, and even the whole list is a list slice. So for example, the sum of the elements here is just 2. The sum of the elements in this slice is -1. And the sum of the elements in the whole list is 10. So what this question is asking for is the maximum subsequence sum. Notice that if the input is all positive numbers, then you can just take the whole list, and that's always the maximum. So this question is really interesting only when there's negative numbers in the list. So for example, in the list that I've drawn, the subsequence that has the max sum is this, and the sum is 11. Notice that the subsequences really do have to be contiguous. That is, they can't have breaks. If they could, well, then I could be really cheeky and just say the maximum subsequence is 3 plus 6 plus 1 plus 1 plus 2 plus 3. But this is wrong, because these numbers don't form a list slice. Notice that the brute force algorithm is just try every slice. But this takes n cubed time, or n squared, if you're doing it cleverly. These are the algorithms which are shown in the 165 course notes, by the way. So what I'm asking you to do is come up with a divide and conquer algorithm for this question. How might that divide and conquer algorithm go? Well, you should definitely divide your list in half, then solve each problem recursively, and notice that on this side you would get 7, and on the right side you would get an answer of 5. But unfortunately, in this case, neither 7 nor 5 is the right answer. And why is that? Intuitively, we've only checked subsequences which are either wholly contained on the left or wholly contained on the right. We haven't checked the subsequences which cross, like this one. So the question is, how do we check all of these crossing subsequences efficiently? The answer is